Hello everyone, welcome back to chemistry class. Today I'm treating a topic which is chemical equilibrium. Now before we can do that, we need to understand the meaning of equilibrium itself. Equilibrium means balanced. Now if you consider a seesaw, that is a plank of wood with support at the center, and then two loads are placed at both ends of that plank of wood like this. You have a load here, you have another one, and there's a support here, and the two loads are balanced, or they are equal. This plank of wood will be on a straight line because the two loads are equal. So but when one load is lower than the other one, the lower load will go up, this plank side will go up while this will go down. So in this case the plank is not yet balanced. So when we are not talking about chemical equilibrium occur in a chemical reaction, and it is denoted as two signs like this. That's a reversible reaction. Chemical equilibrium occur in a reversible reaction and also in a chemical equation. So we see it like this. This sign, the first arrow here is showing the forward reaction, while this arrow is showing the backward reaction. So in this reaction, in this chemical equilibrium and irreversible reaction, we have the forward reaction and the backward reaction. Now, when there is no observable changes in the properties of a system with respect to time, we can say that reaction is at equilibrium. And there are two types we can talk about: physical equilibrium and chemical equilibrium. I've explained the physical equilibrium as in the case of a balanced seesaw, while the chemical equilibrium occur in a chemical reaction. And then what are the properties of this chemical equilibrium? Number one, in chemical equilibrium reaction, the reaction is dynamic. That is, the rate of the forward reaction is equal to the rate of the backward reaction. That is, reactants react together to form products, and the both products also react together to form back reactants. And this reaction occur in a closed system, that is a system whereby none of the products is allowed to escape. Now, how do we now interpret or determine the factors that affect determine the effect of the factors affecting chemical equilibrium? We have three factors actually that affect chemical equilibrium. The first one is temperature, the second one is pressure, and the third one is concentration. So when considering the first factor, which is temperature, to interpret this, we need to understand the reaction we are considering. Is a reaction an endothermic reaction or exothermic reaction? In an exothermic reaction, though I've made a video on that, but in an exothermic reaction, it involves a reaction in which heat is released to the environment. So it means at the beginning of the reaction, there is high heat, and at the end, there is low heat. And in an endothermic reaction, it is absorbed during the reaction. And so it means at the beginning, there is low heat, and at the end, there is high heat. Now, so to determine the effect of temperature, we will use Le Chatelier's principle to interpret that, even in the effect of pressure and concentration. Le Chatelier's principle will be used. And what is Le Chatelier's principle? Le Chatelier's principle states that when a reaction is at equilibrium and an external constraint like changes in pressure, changes in temperature, changes in concentration is imposed on the system, the reaction will adjust itself so as to disannul the effect. Now, what I'm trying to say here is that when a reaction is occurring smoothly at equilibrium, that is the rate of the forward reaction is equal to the rate of the backward reaction, they are occurring at the same rate. And an external constraint, that is there is a change in the system, that is maybe before the reaction was occurring smoothly and then the temperature was increased, and maybe it was occurring at a low temperature. When the temperature changes, that is, has been increased, the reaction would like to adjust itself to bring it back to the normal low temperature. So as that is being done, one side will be favored. More of the product may be formed, or more of the reactants may be formed. And before I forget this, a catalyst does not affect chemical equilibrium, but it can alter the reaction, or it can increase the rate of the reaction, but does not have effect or determine what will be produced, whether more reactants will be or more products are formed, but it can lower the energy barrier and make the reaction occur faster. Now, back to what we are treating. So let's consider this reaction. Nitrogen reacting with oxygen to give you nitrogen to oxide. In this case, we can see that these reactions are in gaseous form. And then another thing is that the heat changes here is endothermic, that is positive. Endothermic reaction is positive. So for you to attempt any question under changes in temperature for your JAMB or WAEC or any other question, or any other examination, you will quickly draft. You don't need to draw boldly, just draft. Consider the heat of reaction. That means you need heat of reaction to be able to attempt any question on changes of temperature, or you need to have an idea of the reaction. Is it exothermic or endothermic? So in this case now the reaction is endothermic, and then to draft that, it means heat was absorbed at the end. So it means at the beginning heat was low, and at the end more heat was absorbed. So low heat, high heat. So it means that for the forward reaction, low temperature is needed to give you products, and for the backward reaction, high temperature is needed to give you back reactant. That is nitrogen 2 oxide reactant to form back reactant, and the reaction occur in a closed system. Don't forget that. That is, none of the products is allowed to escape, so it can form back reactant. Now, in this case now, if I now ask you, what is the effect of increasing the temperature? So the effect of increasing the temperature in an endothermic reaction, in this reaction, according to Le Chatelier's principle, you have to use that. The reaction will adjust itself so as to decrease the temperature. Now let's look at, you've already drafted this and you have written this, that low temperature is for the forward reaction, high temperature is for the backward reaction. So the effect of increasing the temperature is that Le Chatelier's principle, according to Le Chatelier's principle, the reaction will just have to decrease the temperature. Then the side that needs low temperature to be favored is the forward reaction. That is low temperature for product formation, because forward reaction definitely leads to the formation of product, while backward reaction will lead to the formation of reactant. So in this case, you look at this low temperature, which is needed for forward reaction. So equilibrium is shifting to where? Equilibrium is shifting to the right, and forward reaction is favored, and more products are formed. That is the vector of increasing temperature. So vice versa, if you decrease the temperature, according to Le Chatelier's principle, the reaction will adjust itself to increase the temperature, and then for high temperature, more reactants are formed. Now take note of this. Anytime more products are formed, it will affect what we call equilibrium constant. There's something we call equilibrium constant. Anytime more products are formed, there will be an increase in equilibrium constant. Let's look at this reaction now. For an exothermic reaction, you can quickly draft this. For exothermic reaction, it means at the beginning we have high heat, and at the end there is low heat, because heat has been released, lost to the environment. That's why we have it as negative exo. So high heat at the beginning, low heat at the end. You can see the scale, high, then low. So in this case, for the forward reaction, high heat is required to form products, and for the backward reaction, low temperature is required to form reactant. So what is the effect of decreasing the temperature? We say, according to Le Chatelier's principle, reaction will adjust itself to increase the temperature. When we decrease the temperature, the reaction will adjust itself to increase the temperature. And which side needs high temperature? High temperature is needed for forward reaction to form reactants. It means to form products, more products are formed. And if you decrease the temperature, if you increase the temperature, the reaction will adjust itself to decrease the temperature, and this side is low for backward reaction. And so that is the effect of temperature. Now watch out for past questions. I'll treat one WAEC question and one JAMB question on this particular topic before we move to other factors. Now there's something we call equilibrium constant. There's a time we call equilibrium constant in chemical equilibrium. Equilibrium constant is represented as Kc, and then this Kc, which is equilibrium constant, is usually affected by the measure of the product formed or reactant formed. So now take note of this. Anytime forward reaction is favored in a chemical equilibrium, that is, in a forward reaction we have reactants reacting together to form products. So anytime more products are formed, equilibrium constant will increase. Now consider this reaction, N2 plus O2, that is nitrogen reaction to react with oxygen to give you nitrogen 2 oxide. Now in this reaction, to write the equilibrium constant, we look at the number of moles on both sides, and if the reaction is involving a solid, you won't write the equilibrium constant for that. So for this one, we have 1 mole here, 1 mole here, and this will represent their concentration. So the product will always be on top, while the reactant will be written down. Now we have 2 moles of nitrogen 2 oxide here, so we have nitrogen 2 oxide, and since we have 2 here, it will be written as square, that's superscript. Then nitrogen is down, nitrogen multiplied by, as you have more than one reactant, it will be multiplied by the concentration of oxygen. So because these are in brackets, it means the concentration is needed. The concentration of nitrogen, we have multiplied by the concentration of oxygen, and we have 1 mole each, so we have 1 here. Now, how do we determine increase in concentration, equilibrium constant, or decrease in equilibrium constant? Don't forget I said if the equation is involving solid or whatever, it will not be written. So in this case now, if you have more product, let's assume the concentration of product here is 100, and the concentration of nitrogen is 20, while the concentration of oxygen is 2. Now, if you use this, you have 100, 20 multiplied by 2. 100 squared is actually 1,000, is actually 2, that is 10,000. And then we have 20 multiplied by 2, that's 80. By the time you divide it, you will definitely get a whole number value. Now, what if reverse is the case? Maybe you have the concentration of nitrogen 2 oxide to be 80. In this case, I said we have 10,000 or 80. Definitely it will give us a positive whole number. But assuming the concentration is like of the product is 80 and that of the reactant is 1,000, you definitely get something like 0.00080. So in this case, this is less than 1. So when the equilibrium constant is less than 1, it means that we have low product, more reactant. But if the equilibrium constant is more than 1, it means, or is equal to 1, it means that we have high product on top, low reactant down. So anytime more products are formed, equilibrium constant will increase. So that is on that. Watch out for the effect of pressure and the effect of concentration and the past questions on that. Now, another factor that affects chemical equilibrium is pressure. How does pressure affect chemical equilibrium? Number one, pressure as a factor only affects reactions involving gases, and it doesn't have any effect on reactions involving solids. And there are 2 conditions. Number one, which I've mentioned, the reaction must be in gaseous form. Consider this reaction, the Haber process, in which nitrogen gas reacts with hydrogen gas to give you ammonia gas. We can see that all these reactions are in gaseous form. Also, another thing is that the total number of moles on both sides of the reaction, that is on the reactant and product side, must not be equal for pressure to affect the reaction. Take for instance now, the total number of moles on the reactant side is what? 1 plus 3, that is 4. Now, on this side we have 2. We can see that the total number of moles on both sides are not equal. So pressure will have effect. Now let's consider this reaction. The second reaction here involving the liberation of hydrogen gas. When steam, that's steam in gaseous form, water in gaseous form react with ion, red hot ion. Now in this case, ion is a solid, this is steam, this is also a solid. And in this reaction, we can see that the total number of moles on both sides are equal. Do you know why? We don't look at it like this is 3 plus 4 to give you 1 plus 4. No. What we look at is this. The reaction involving solids here are not considered. The only thing considered here is the water and the hydrogen gas. That's 4 moles of hydrogen gas. Since both sides are equal, pressure will not have any effect on the reaction. So number one, pressure only affects reactions involving gases. Pressure also affects reactions in which the total number of moles on both sides are not equal. So let's consider the effect of pressure on the first reaction here. If you have a question and you're asked to determine the effect of pressure, what is the effect of increasing the pressure? Now, to determine that, you will still use Le Chatelier's principle. According to Le Chatelier's principle, if a reaction is at equilibrium and an external constraint is imposed on the system, that is, the reaction is occurring smoothly, and an external constraint, that's changes in temperature, pressure, or concentration, is imposed on the system, the reaction will adjust itself to bring it back to the normal. That is, maybe the reaction was occurring at a low temperature, at a low pressure, and then you just change the system maybe by increasing the pressure. The reaction will try to adjust itself to bring it back to the low pressure, and as that is being done, one side will be favored more than the others. So let's quickly look at this. What is the effect of increasing the pressure? According to Le Chatelier's principle, the reaction will adjust itself to decrease the pressure. Now, the side that has lower number of moles needs low pressure. The side that has higher number of moles needs high pressure. But because the pressure was increased, and according to Le Chatelier's principle, the reaction is adjusting itself to reduce the pressure, what will be favored is this side with lower number of moles. Just so, okay, more reactants, more products are being formed. And anytime more products are formed, equilibrium constant is increasing. Now, if I ask you, what is the effect of decreasing the pressure in the first reaction here? According to Le Chatelier's principle, the reaction will adjust itself to increase the pressure. The side with a greater number of moles, that's 3 plus 1, is 4. That's the reactant side. That is what will be favored, and more reactants will be formed anytime more pressures are formed. So in this, anytime the pressure is increased, so we can use this to actually determine what will be produced in a reaction. That is the principle behind industrial preparation of most gases, even in the EBA process. And we alter the conditions to determine what will be formed. And in any reactions, we always after products formation. So if there is a change, so in this case now, it means that when there is high pressure, the reaction we are just left to bring down the pressure, so favoring the product formation. And so it means reverse is the case to produce more reactant. So watch out for other effect, which is the effect of concentration. How do we determine the effect of concentration in a chemical equilibrium? Consider this reaction, calcium triazocarbonate 4 reacting or decomposing to give us calcium oxide, which is quicklime, and carbon 4 oxide. You can see that this reaction is a reversible reaction. Now, there are 3 factors that affect chemical equilibrium: temperature, pressure, and concentration. Temperature and pressure has been treated in earlier. Now, in this case now, we determine the effect of concentration by interpreting the effect of removing one of the products. Now, assuming this reaction occurs in a closed system in which none of the products, as the products are being formed from the reactant, the product is reacting back to form reactant, none of the product is escaping, we can say that we may not really get the effect of concentration. But if this carbon 4 oxide, for instance, as it's being formed from calcium triazocarbonate, as a part of the carbon 4 oxide is being removed, it means that no product will react again to give you reactant. So automatically the reactant will reduce. If we reduce the product, the reactant will reduce. How? Now, if you remove part of the product, all the reactants will be used up to form more product. More product will be formed because all the reactants will be used up. And along the line, the product form will not be able to go back to form reactants. So there will be no more reactants while more products is formed. And if you increase the concentration of the products too, more reactants will be formed. So it's still using the principle of Le Chatelier's principle, which says that when the reaction is at equilibrium and an external constant is imposed on the system, the reaction will adjust itself to disannul the effect. That is, when you increase a system, you increase the condition in a system, the reaction will adjust itself to bring it back to low system. And that is the principle behind equilibrium. And if that is being done, one side will be favored, while one side will not be favored. Watch out for the past questions series on this topic, which is chemical equilibrium. Thank you. Don't forget to subscribe to my channel on YouTube, Olabisi Olawoye, and press on the notification bell. Share my video, like my videos, and also follow me on Facebook, and that is of Olabisi Olawoye. That's my Facebook name. Thank you.